recording. Are there any questions before we get started today? We're still, I'm still working on VLANs and working on inter VLAN routing and DTP and those things, but I wanted to just open up for any quick questions. I know Jacob's got a question about how you set a the native VLAN on a trunk link, and I'll talk about that in just a second. But any questions overall that you have at this moment?
Can you go back over authenticating to the lab there at on your premises?
Yep. All you gotta do is this: go to netlabs.stanley.edu, put in your username and your password. And
it should be the same password as that we're using for Canvas, or it should be
no, it's a different password. You would have set it up when you did the labs last class.
If I need to reset it,
I can do it. I had to do that. So give me 1 second and I'll reset it for you.
Okay, that'll be great, because I don't remember what the password was. And which is be a bad thing.
Yeah, let me go in here real quick and I'll reset it for you, Denise. Let me find your email address, what your account name is too. The account should be your it's your full Stanley email address is your.
Yes.
Okay, and that's, yeah, because you need to get logged in and do some labs, because
yes, I need to get some stuff finished. That's kind of holding me
up. The first one too.
Yeah, I need to get that done. That's my intent of things to do this week.
Okay, Cisco 123.
Okay.
So you go to netlabs.stanley.edu, put in your email address and Cisco 123.
Thank you.
You're welcome. Okay, so that's how you get in there. I want to talk just a second. We've already talked a lot about this, but talk a little bit more about VLANs and about the fact that when we think of a VLAN, we need to think of the VLAN as a subnet. So if I handed you the network 192.168.12.0 and said that we're going to have ports 1 through 4 on VLAN 10 and ports 5 through 8 on VLAN 20, and then all other ports are going to be on VLAN 999. Now, what I'm going to tell you is, if it's a black hole VLAN, that means it's a VLAN that you park all of your unused ports on, and you don't have to do any. You don't have to actually have a real network for that VLAN, because you're not going to use it for anything. It's just somewhere to keep your ports so they're not sitting in VLAN 1. So if I came to you and said, let's subnet this network for these two VLANs, and they need to be equal sized, you would very simply take this and borrow 1 bit, make it a /25, and so 0 to 127, and 128 to 255. And so the network address for your VLAN 10 would be 192.168.12.0/25, and your VLAN 20 subnet would be 192.168.12.128/25. First usable IP address on VLAN 10 would be what? What would be the very first usable IP address if I did this subnetting? Anybody? What's the first usable IP address in this subnet right here? It's .1, right? What's the last usable IP address in this subnet? 126. That's /25. So that's our usable addresses for that subnet. How about this one down here? What's our first usable address in the 128/25 subnet? Come on, y'all. Speak up now. It's 129. Because it's remember, this is the subnet ID. That's the broadcast ID. So the first usable is 128. The last usable is 254. All right. So we subnetted this major network into these two subnets, and that will fit our scheme here for these VLANs. What that allows us to do then is this. Let's go over here and open up Packet Tracer and actually build this real quickly, because we can do it in a very simple format. So we've got, remember, when we're creating VLANs, what's the process? 1, create the VLAN. That's an A. Create the VLAN. And then 2, we assign ports to the VLAN. All right. So if we're looking at this packet tracer right here, and I'm going to pull this over. We'll pull out one switch. Pull this out here, put that there. Move this over just a little bit so we can see. We'll pull out one switch here. We're going to go in that switch. We're going to go into CLI on it. It's going to take it a few seconds to boot. Unlike a real switch, it takes just a few seconds. So the first thing we would do is go in here. Now, normally we would already have our full setup in terms of host name, passwords, all that stuff. But all we're going to do on this now is we're going to do a VLAN 10. So that creates that VLAN, give it the name of faculty. We're going to do VLAN 20 and give it the name of students. And then we're going to type exit to drop back, and we're going to do interface range FA0/1 to 4. Okay. We'll do switch port mode access. Remember, these are going to be ports that are accessed only by a single host, so they're not going to be in more than one VLAN. And it will be switch port access VLAN 10. Hit the up arrow twice because we're lazy and we don't want to redo things. That's 8. Up again, access. Remember, that up arrow is your friend. Now you'll notice if I do a do show VLAN, you should see that we have the ports 1 through 4 in VLAN 10, ports 5 through 8 in VLAN 20. Now we want to park all the other ports on a VLAN called 999. So what we're going to do in here is we'll type exit, we'll type VLAN 999 name black hole. So this is where we're just going to stick all the ports that are not in use. So I would go exit here. I'd do interface range FA. So I know it's got to be FA09 to 24 because that's the ports are left. And I also know that it's gigabit 01 and gigabit 02. And I just know these switches that well. I know what ports are there. I'll do switch port mode access, switch port access VLAN 999. Do show VLAN. You'll see now that all the ports, no ports exist in VLAN 1 whatsoever. So we parked all of our ports over on a black hole VLAN. Now, that's neat. That's awesome. But one of the things we need to talk about is we need to talk about how we do trunking. In other words, what if I needed to connect to another switch over here, and that switch needed to be able to hold the same VLANs? Well, first off, I'd have to recreate the VLANs on that switch. That's one thing we'd have to do. So I'm not going to do that right this second, but I would have to. But I need to create a trunk link between switch 01 and switch 1. So I'm going to make a connection here. Now, what is the purpose in a trunk? What does a trunk link do? What's the difference between a trunk link and an access link? So you saw me use the command switch port mode access. So you know we've got access ports.
Well, the trunk link carries the Q tag, which will allow a device on one VLAN to communicate with a device on the other VLAN via the switch.
Okay, it won't be on the other VLAN, but it'll be able to communicate with other VLAN members on another switch.
It also put the interface into permanent trunk mode and negotiate it with to the neighbor link into trunk link.
So one of the keys here is exactly what Steve said and what you said, Jacob, is that is the .1 Q tags are maintained across, okay, the trunk link. So in other words, a trunk supports the ability to move tagged traffic. Access ports do not support tags, so they are not or do not support tags.
And Kelly, forgive me, but I'm on my mobile phone. I'm in transit right now, trying to get to the house on a computer.
That's okay, no problem at all. Just be careful. Don't get in trouble driving.
Now, hands-free.
Excellent, excellent. Just safety first, always. So what we're going to do is we're going to make this a trunk. So I connected port gig 01 to gig 01. So let's go in here now. Now, right now on this particular switch, it is connected to, I've got it in the black hole VLAN. So what we're going to have to do, we're going to have to exit out of here. We're going to have to go interface GI, the G01, and we're going to switch port mode trunk. All right. Now we have some options. The next option is this, and Jacob, this was what you asked about. You asked, how do I set the native VLAN for a trunk? Well, first off, if you don't set the native, by default, the native VLAN is 1, okay? But if you want to change the trunk's native VLAN, you simply use the command switch port trunk native VLAN 999. And now if I do a show int trunk, you will see that the native has been changed to 999. So I'm going to go over here to switch 1. I'm going to take the port gig 01 and do config T, and that's like the host. This is actually S2 int G01 switch port mode trunk switch port. Notice how it's saying there's inconsistent local VLANs because there's different BPDUs being found. In other words, it's saying there's a native VLAN mismatch on this trunk. So switch port trunk native VLAN 999, that'll fix that issue. So the consistency restored. So now if I do a do show int trunk, you'll see that we can actually see the trunk working between switch 1 and switch 2. Now I'm gonna real quickly just remake these VLANs here. So I'm gonna say VLAN 10 name faculty.
But while you're doing that, doesn't naming or renaming the native VLAN kind of defeat the purpose of parking them in a black hole to begin with?
Yeah, I agree with that.
The question I asked too.
Yeah, I agree with that. I do agree with that. But you ask about the native. I would probably in this case set it the native VLAN to something other than the black hole VLAN. I'd set it something like 200, something not being used. So yes, you're right. I agree with you, Steve. That is kind of defeating the purpose of the black hole VLAN. But Jacob had asked how to set it to 999, so that's why I wanted to show it. But I'll change it back. I'll change it.
Okay, now I understand. I just wanted to make sure that we were on the same page with that.
No, you're right. So what I'll actually do now is I'll do int range FA0/1 for switch port mode access, switch port access VLAN 10. So right now I'm gonna just put and then I'll do the next one. I'll do the 5 through 8. I'll put these in VLAN 20.
Can we say that if the port is that associated with the native VLAN, then it is the access port?
Say that one more time, Dr. Who?
If we let a port to be inside the native VLAN,
Okay.
now can we say that that port is an access port? It's not the trunk port.
Okay, very, very good question. Okay. Technically, what you are saying is true for that one VLAN. So in other words, what this does when I set the native VLAN to 999 is it says do not tag 999. So honestly, what's actually happening is to the gig 01 port, it thinks VLAN 999 is an access port. There's an access VLAN.
Okay.
All other ports, or excuse me, all other VLANs will be tagged. So it's only not tagging that one VLAN.
Right.
So what I'm going to actually do is for best practices, I'm actually going to do what we're suggesting. I'm going to say native 200 on this side. I'm going to go back over here because this will break us if we don't fix it. I'll do 200 on this side. So actually what you're going to see now, if I do a do show int trunk, you'll see that we've got a trunk and our native VLAN is 200. So that's some VLAN that doesn't even exist. we do a, over here on this switch one, we do a do show VLAN. You'll see we created our VLANs. We got our students in those, we got our ports in those VLANs. We got everybody else in the black hole, and we got one trunk port, which is gig 01 between the two switches. All right. So right now, if we're looking at our curriculum, we're really at the point to where we have created a trunk between the switches, just like this right here. So we've got our VLANs, we've created our trunks. We are going to support the ability for traffic to be tagged between switch 1 and switch 2. So if I go back over here to my example I've given you, all right, and I put a PC on here. So I take and grab a PC, all right, and I'm gonna put one over here. So I'm gonna put this PC on the left into port 1 of the switch, and I'm gonna put this PC here into port 1 on the switch. They're both in VLAN 10. So using my example here that we've got, so I'm going to use my subnet, my slash 25.0. I'm going to give this PC the IP address, physical desktop. I'm going to give it the IP address of 192.168.12.10 with a mask of 255.255.255.128 because it's slash 25. All right. Right now, there's no default gateway. We don't have any router here, so there's no default gateway. We're going to get to that in just a second. I'm going to go over here to the PC1 desktop, give it the IP address of 192.168.12.11, 255, too many fives, 255.255.255.128. Okay. Oop, I put wrong. I put 150 instead of 128. So let me do this again. 192.168.12.11. 255.255.258. All right, so that's good to go. So now I can go to this command prompt, do an IP config. I can type, you'll see that I'm 12.11/25. I'm going to ping 192.168.12.10. And I'm able to ping all the way across from PC1 over to PC0 going across this trunk link. Now, if I put another PC in here, okay, so I'm going to put another PC in here and put it in port 5. So it's going to be on a different VLAN. It's going to be on VLAN 20. So even if I gave it an IP address in the same network, it would not be able to ping any one of these other two PCs because to this switch, this PC exists in VLAN 20. The other two PCs exist in VLAN 10. So let's go ahead and put another PC over here. And so we're going to do the same thing. We're going to connect this to port 8 or to port 5. And we're going to give these PCs IP addresses in our second range. So 192.168.12. I can't type. 192.168.12. And we'll do 139. And we'll do a slash 125. Okay. And then we'll go over to this other PC, PC3 desktop. We'll give it 192.168.12.140. We'll give it the mask of slash 25. Now we go to this command prompt, do an IP config. I'll be able to ping from 192.168.12.140 to 139. No problem. So I can ping across. But the second I try to ping 12.10, it's going to fail because for two reasons. One, it's not on the same network as that. And I don't have any connectivity between my VLANs. So what we've got to be able to do is now we've got to figure out how to do this inter VLAN routing. We got to figure out how do we route between our VLANs. Well, there's two ways to do this. There's a legacy mode, and then there's our more recent mode, which is called router on a stick. So I'm going to do legacy mode first. So let's imagine, going back to our example, that I had this network right here. I could very easily pull out one router. Okay, so a 4321. All right. I could go in here and take one of its interfaces, gig 000, and connect it into port 2, which is on VLAN 10. I could go over here and connect gig 001 to port 6, which is on VLAN 20. Now, pulling our examples up, we know the first usable address is 1 on the first subnet, 129 on the second. So go to our router, go to our command line. We're not going to do that. We'll go into here, config T, interface gig 000, which is the one connected to VLAN 10. We'll do IP address 192.168.12.1, 255.255.255.128. No shut. Then we're going to hit the up arrow until we get to gig 001. I'm going to do that again just to make sure I got there. And on this one, we're going to put the IP address of 12.129. And we'll do a no shut. So we have created a router that will route between these two. Now watch what happens. First off, it won't do it because you'll notice when I come in here and try to ping, it will fail because we did not put onto our configuration, we didn't put our default gateway. So we've got to go in here and set our default gateway, which on this side is 192.168.12.129, because this is our second subnet. So let's go and do that on both of the host here. It's at 129. All right, so that's good there. And then on the other host, we need to set it to 12.1 because it is in the first subnet, 192.168.12.1. Close that and we'll go back over to PC1. Desktop. Got to change this. 192.168.1. Now, if we go to our command prompt, we should be able to ping 1210, which is on the other side over there on switch 0. We should be able to also ping 12.139. I may take it just a little bit to figure it out. So now we have connectivity because what's happening now, watch this. I'm going to put this in simulation mode. I'm going to ping from this PC, okay, to this PC. Now let's watch what happens. It comes up, it goes up to the switch, then it goes up to the router, comes back down, gets blocked here because it's coming in twice. Goes there. And what's that? Is that ARP? Oh, wait a minute. That was dumb. I pinged between the same thing. Hold on a second. Let me do real time. Go back to simulation. I pinged between the same subnet. All right. I got to ping between two different subnets. So I'm going to ping from PC1 to PC1, 2. Yeah. Okay. So now, it's going to go up. The red one should go up to. All right, I'm doing something wrong. There it goes. Okay. It's going to the router and getting routed. So in other words, what's happening is if I'm pinging from PC1 over to the other VLAN, it goes up to the router. All right. Connects to the router and then gets routed and comes back down to PC2. Now, the way I built this network is a little weird because probably what I would have done in the real world is I would have done this. I would have actually gone in here and let's see if I can get this. My delete tool. I would have probably actually done it like this. Connected this directly to the other side, which is 6. And so that the router is not connected to both switches. So now if this PC, let that come up. By the way, why is that orange? You remember us talking about spanning tree?
Yeah.
It's going through the 5 steps: blocking, listening, learning, then goes to forwarding, takes it up to 50 seconds. If this was a host port or an access port, we could put on there port fast. We don't ever want to put port fast on a link going to a networking device. That's actually a major mistake. We don't want to do that. So now that it's up, you'll notice that I'm able to ping. Might take it a second to learn the ARP table, but because we're going to have to clear the ARP table out. But there you go. You'll see I can ping from 12.10 or 12.11 up to 12.139 or 140. So now I have connectivity between the two VLANs. I have VLAN 10 talking to VLAN 20, but I'm doing that because this router has a port in each one of the VLANs. This is called legacy inter VLAN routing, because you have to have a single port for every VLAN. So this will not work in our modern networks because we have more than a couple VLANs. We may have 30 VLANs or 40 VLANs inside of a building. So there's no way we can do inter VLAN routing like this. So there's another method. It's called a router on a stick. So what we need to do is figure out a way that the router's physical port can support multiple VLANs. And we do that with a concept called sub interfaces. So we're going to create a trunk link up to the router. We're going to trunk between the router and the switch. And then we're going to use that to move all traffic between the two VLANs. So let's go back to our example right here. And I'm going to delete both of these links. Okay, and I'm going to go back into my router, and I'm actually going to go in and do no IP add, and then I'll go into the other interface, which is gig 01, and also do no IP add. So no IP address here on either one. So if I do a do show IP int brief, you'll see there's no IP address whatsoever on either interface. So I will go back to my network though. And we're going to connect a single link from the router's gig 000 port to gig 02. So we're going to create gig 02. Now I'm going to go into gig 02 on the switch. I got to make it into a trunk. So I'm going to do config T because I got a trunk between them. See this picture right here? We're trunking from the switch to the router. So whatever port's connected to the router, we got a trunk. So we'll go in here. Let's get back to our router, back to our switch. Sorry. All right. So it's int G02, 2, not 3. Switch port mode trunk. Switch port trunk native VLAN 200. All right. So we got that side working. I'm gonna do a no shut on it. And then now we go back to our router. And on the router, we're going to take and go to interface gig 000. But instead of configuring the physical interface, we're going to configure the sub interfaces. And we need one per VLAN. So we go gig 000.10. Okay. And we'll do encap.1q. And then our VLAN ID. So in this case, this is going to be VLAN 10. By the way, it's not necessary that your sub interface number and the VLAN ID match, but it's the best way to keep up with things. So we'll do that. And then we're going to put the IP address of 192.168.12.1, 255.255.255.128. So still using the exact same networks that we have here. And then we're going to do another sub interface to support VLAN 20. So there's 20. Associate. Now what this does is says everything on this interface, tag it with VLAN 20. It's going to be tagged with VLAN 20. And we put in the IP address of 129. All right. And then last but not least, we could do one for the black hole if we wanted to. I'm actually not going to do that. And at this point, you will notice that if I type exit, all right, and exit and do a show IP brief, I've got two sub interfaces. One of them's on VLAN 10, one of them's on VLAN 20, and they're on those two addresses. So if I go back to the PCs in my example network, I should still have full connectivity and the ability to ping between them. It may take a second for it to come up. The only thing I may have to do is I may have to go in, there it goes. So I have full connectivity between the two sides. So again, if I do an IP config here, you will see that this is on that first subnet. This is on the subnet 1, let's see, /25. And I'm able to ping over to the other subnet, no problem. So it's going across this trunk link. It comes in, gets tagged as part of VLAN 10, excuse me, actually in this case, VLAN 20, comes across, comes up to the router. All the tags are maintained. The router routes it over to VLAN 10, maintains its tag till it comes down to the destination, and then is delivered to the destination. So we now have a router on a stick. There's some good things and bad things about routers on a stick. The good news is you don't have to have a physical port for every single VLAN. The bad news is those VLANs are now sharing the bandwidth for that particular link. So if it's a slow link, then those VLANs have to share.
And the VLAN cannot be more than 50.
Say again, Jacob?
Or they say it cannot go beyond 50 feet line.
Yeah, and I agree completely with that. Yeah, you don't want to put too many, because if you do, it will definitely overwhelm the ability of the link to move traffic. So that's how we route between VLANs. Questions about that? Questions about how we do that? Because it's really pretty simple. We take a physical interface, we break it into sub interfaces, and those sub interfaces are associated via encapsulation with a particular VLAN. All right. So again, very simple. We create our VLANs, give them a name. We create the management interface on our switch. We configure the ports, and then you configure your trunks, and that's what you do there. And then you set up on your router, you set up your sub interfaces. So here's the ability to do your sub interfaces. Again, typically we do try to make the VLAN ID and the sub interface ID match, but it is not required. This could have just as easily been gig 001.25 and it be for VLAN 10, but it just makes no sense. So we try not to do it that way. We try to make them match. So typically for every net VLAN you will have a sub interface that is associated with that VLAN. All right. Now I want to back up 1 second to just show you VTP here, because we didn't talk a lot about it. We talked about creating trunks and the fact that you can do switch port mode trunk on both sides of a switch link so that they will actually form a trunk. There's actually in Cisco a protocol that's actually very, very dangerous, because it allows you to do automatic trunk negotiation. It's called dynamic trunk protocol or dynamic trunking protocol. And with this, which is turned on typically by default, if you connect two switches together and they have the correct mode, they will try to negotiate. Now, typically we want to turn off DTP. That is this command right here, switch port no negotiate. That turns DTP off. And most of the time I tell people, whenever you're doing trunks, this is what you do right here. Switch port mode trunk, switch port no negotiate. Turns DTP off, no worries, okay? If, however, for some crazy reason, you want to use DTP, you'll see there are multiple modes that you can put it in. One is access. And if you put a switch port in access mode, it will not be a trunk. Switch port mode access means it's an access port that can only be associated with one VLAN and will not maintain tags across that link. If you put dynamic auto, it says that it will try to become a trunk if the other side is set to desirable or trunk. If you set it to dynamic desirable, it will attempt to become a trunk if the other side is set to desirable, trunk, or dynamic auto. Now, if both sides are auto, they will not become a trunk because it's going to say, hey, I'd like to be a trunk if you'd like to be a trunk. And then the other side says, I'd like to be a trunk if you'd like to be a trunk. It's kind of like when you and your significant other say, hey, where do you want to go to eat? I don't know. Where do you want to go? I don't know. Where do you want to go? You know, if somebody doesn't make a decision, you'll sit there for 30 minutes trying to figure out where to go eat. So if both sides are dynamic auto, it will not automatically become a trunk, which doesn't make a lot of sense, but it basically is that neither side can make its mind up. If one side is desirable and the other side is either set to trunking, desirable, or dynamic auto, it will become a trunk. And this is where things get dangerous because a hacker can put their machine onto your network and running programs that allow them to say dynamic desirable on their interfaces. They can start grabbing all of the broadcast traffic on all your VLANs. So this is why we typically turn off DTP with this no negotiate command. But you'll see here, if one side's dynamic auto, the other side's dynamic auto, it will be an access port. It is not going to trunk. Desirable auto, trunk. Trunk, auto, trunk. So pretty much if it's auto, the only time it will ever become a trunk is if the other side is either already trunking or desirable. DTP is dangerous in the real world. I would almost always tell you that if I'm setting up a trunk across between two switches, I'm going to go into do show run. I'm going to go into that port that I'm trunking on. So you can see here, I'm trunking on this right here. I'm going to do switch port mode trunk. And actually, I should be doing on these. So let's go int G00 or G01. Switch port, no negotiate. And I'll do the same thing on 2. And that just makes absolutely sure that turns off DTP. We'll write it, and that way we've turned off DTP on our 2 trunk ports.
I could probably miss the point here. Why do we need to avoid that auto negotiation?
Okay. All right, let's say we've got this network right here. We have not turned off DTP, okay? So we have a port, and let's say that port is, well, first off, let's say we didn't park them in a VLAN. We didn't park them in a black hole VLAN. See, we're smarter than most people. We're not going to run into some of these problems. But let's say we have a port we have not parked in a VLAN, in a black hole VLAN, and in that port, we have not turned off DTP. Okay, are you with me so far? You understand that? So in other words, we got a port here. I'm gonna pull this out to a whiteboard so I can draw on it. Okay, so this is what we have. So we got a port down here, and that port is DTP has been left on. And we forgot to put it in a black hole VLAN. So I'm a hacker. I take my laptop. I'm evil. Okay. I take my laptop and I connect it to that port. Well, in my version of Kali Linux or whatever hacking tools I'm using, it lets me turn DTP on right here. All right. So this side is set to DTP auto, okay, which is typically what it's set to. Well, I set mine to DTP desirable. Okay. What happens now is this becomes a trunk through auto negotiation. Every time a broadcast goes out from any machine, so if a broadcast comes in, it's going to go across all the trunk links, right? Well, guess what? As soon as I join this trunk link, I can now grab every single bit of that traffic. I'm able to see all the broadcast traffic on all of your VLANs because my hacking box has a trunk to your switch. That's why we turn off DTP.
Okay.
DTP is basically leaving your back door unlocked.
Exactly. It exactly is what it's doing.
So now here's another question. Why we invent DTP in the first place?
You know, that is a really good question, Dr. Hu. Honestly, I don't know. you know, it does make life simpler in that you could just easily make one side dynamic, one side auto, and it becomes a, but it makes no sense to me. I don't know. I cannot even begin to tell you why. You know, how much harder is it to do, quite honestly, the command switch port mode trunk versus switch port or dynamic desirable versus, you know, the commands are so short. I guess in the early days, Cisco thought maybe it was easier for network admins who didn't know how to do trunking, but I honestly don't know.
We didn't have the hacking issues we have today.
That's
I
part
mean,
of
it's
it.
like Telnet. It was a kinder, gentler time.
Agreed. That is part of it. And I think too, they never, physical security was not something they really thought as much about as they do now. They thought, well, the switch is going to be in a closet that nobody can get to, so no one's going to be able to plug in to that. Well, they forget that on these switches, every single one of these goes to a wall plate, right, in some room, and then anybody can plug into them. And so they didn't really think about the fact that it was a big security hole. So if you do much reading on DTP, 99% of the things you'll read is turn it off. So the beauty of it is, if you did just simply do one of our suggestions, so in other words, if you parked all of the unused ports into an unused VLAN and shut them down, you stop your DTP attacks also, okay, for the most part. Because, you know, you also have set all of these ports to be access ports, so you don't have to worry about somebody unplugging your PCs and plugging in their machine and DTP working. So turning DTP off is an additional layer of security that will allow you to not have to worry quite as much.
Okay.
But Dr. Who, I really don't know. I mean, I've looked, and the only thing I can find is it was for ease of use and simplicity, but that's it. Okay, so we've got our legacy inter VLAN routing, which requires a port per VLAN. We've got our router on a stick, which lets us do sub interfaces. Okay, and then there is another thing we have, and this is a layer 3 switch. So there are switches out there that support the ability to create switch virtual interfaces and to route between those interfaces. In fact, believe it or not, our even our little 2960s can do this. But if I go into Packet Tracer, I look at my network devices. Let's go, sorry, wrong one. Network devices.
So the switches we usually talk about are layer 2 switches.
Correct.
So this layer 3 is that's network layer switches. That's something similar to router, right?
And basically, it's a switch that has capability to route. That's exactly what it is. So let me show you that. Let me show you how that works. So let's imagine, and we're going to actually just build this little network right here that they're showing. We're just going to build this real quickly. And this is something cool about Packet Tracer that's a little harder to do in NetLabs because we don't have as many layer 3 switches. But this is a layer 3 switch. It's called a multi-layer switch. So it's still booting, so let it boot here. But we're going to go in and we're actually going to do exactly what they've got here. So, or get close to it anyway. So let's do EN, let's do show IP and brief. I always do a quick look at the interfaces. So this is all fast Ethernet, so that's all good. So we're going to do a config T. We'll call this host multi-layer switch. And so I'm going to go in create VLAN 10. Name faculty, VLAN 20, name students, and I'm gonna stop there. I'm not gonna go any further. Then I'm gonna do interface, interface range, FA01, 0/1 to 4, switch port access, mode access, sorry, switch port mode access. Switch port access VLAN 10. So I put those into that, hit the up arrow because I'm lazy. Actually, I'm not lazy, I'm efficient. That's what I'm saying. Mode access, and this will be in VLAN 20. Well, now instead of going out and getting a router and routing between those two VLANs, since this switch supports it, first off, we're going to make sure IP routing is turned on. So we'll just do IP routing. It's probably already turned on, but I just do that to make sure. Then we're going to go interface VLAN 10, and you'll notice it creates a VLAN. IP add 192.168.12.1.255. I'm using the same two subnets I had in my last example. So no shut. Okay. And then I'm going to do a VLAN, interface VLAN 20. And then I'm going to do the same IP address I had again in my other example with a no shut. Then I'll do a do write, Control Z, show IP brief. You'll see now I have two routable ports, 12.1 and 129. So I actually can go between those two. And I'm gonna go put me two PCs out here. So I'm gonna grab me two PCs. And I'll put one on VLAN 10 and one on VLAN 20. And give them IP addresses, and we'll watch what happens here. You'll be able to easily route between these, but the switch itself is doing the routing. There's 5. So let me put IP addresses on here. So this will be 192.168.12.10, 128, and then our 192.168.12.1. So that's the IP address you'll notice that is on the VLAN 10. So that's our first routable port that we're going to have. And then we'll go over here to this PC, and we're going to give it 192.168.12.130. Let's do 140 because it's easier to remember. And that's on the other subnet that we created. And 192.168.1.129 to here. Now I'm going to go to my command prompt, and the first thing I'm going to do is IP config to make sure it took, and it did. And I'm going to try to ping my gateway 192.168.12.129. Works like a charm. So I'm pinging VLAN 20 switch virtual interface. I'm going to ping 12.1. It should work. If it doesn't, I did something wrong here, which is possible. Let's go to the other PC and make sure it can ping its default gateway. Okay, so that works. Oh. All right, so let's do this on this. Let's do a show IP route. Now we got both of those. So we got our networks. Ping 192.168.12.10, 12.140. All right, so we can ping both ways that way. So something's telling me that I've got something wrong with this PC. 192.168.12.10, 125. Okay, so that is correct. Sorry, y'all can't type. So that is correct. I can ping. I can definitely ping between the two. Hold on one second. Hold on one second. Let me check something. Folks, we have a thunderstorm going on here. I may, if the power drops, I may get dropped. Okay, oh, that's right. so let's go back in here. So we're able to ping. At this point, we should be able to ping across, folks. I actually don't know why we're not pinging across. Yeah, see, that's, I know I had to have that on. Yep.
How about the IP address of the two PCs?
Yeah, I think I'm pretty sure I've got them right. I think this is something to do with, because it's 192.168.12.10/25. 12.1 is, and let's make sure that's in, what port's that in? We can hover over it. Port 01. And 01 is in, I do show them, and I can't type. Is in VLAN 10. That is correct. So let's go back over here and let's do this. IP config 192.168.12.140. Got that. 192.168.1.129. Oh, there it is right there. Dun, dun, dun. Typo. Typo. All right, there's 12.129. So 12.1 works now. 12.1 now works. And guess what? 12.10 will now work. Simple typo. All right. So there we have, this is a layer 3 switch. And so in this particular network, we created two sub interfaces. You'll notice those two sub interfaces. If we go in here and show IP int brief, you'll see the two sub interfaces are switch virtual interfaces VLAN 10 with that IP address and VLAN 20. Now we did have to use the command IP routing, which turns on the ability to route between the two subnets. But then after that, and if we put in the correct default gateway for the PC, we can ping all the way across, no problem. So that's an example of a layer 3 switch. In other words, it's a switch that has the capability to route. Most of the switches we deal with in our CCNA work, we consider them to be layer 2 switches. They're not layer 3 switches. So here's an example. You create your VLANs, create your SPI interfaces, configure access ports, and then you have to enable IP routing, which that's where most people forget to do the IP routing.
Can we say about routers? That certainly more than just switch plus the routing, right? But probably not switching, but routing.
Exactly. Yeah, it's able to route at this point.
Just for route.
Yep. You can even with a layer 3 switch like this, you can even connect it to a router and then have it route, send routes back and forth between that router. So if you'll notice, if I look at this switch,
they don't have enough port basically for route.
Right, exactly. If I do this though, if I do router ? You'll see that this actually supports the routing protocol BGP, EIGRP, OSPF, and RIP. So this router could connect to a router that was going externally and actually route to an external network if it needed to.
So the layer 3, the router is much more expensive and powerful than regular router.
Yes, exactly. Yes.
Okay.
Layer 3 switches are much more expensive, much more powerful because they have to have the ASICs, those application-specific integrated circuits, to not only do the switching, they've got to be able to do the routing. So they've got to be able to tear things down to layer 3 instead of just to layer 2. So yes, definitely, they're much more expensive. Okay. So that is our layer 3 switch, and that is how we can use a layer 3 switch to do our inter VLAN routing. And it is probably the most common method now in real networks. So in other words, like in our building, the building I'm sitting in, we have a layer 3 switch that sits in the building. And then that layer 3 switch routes between all of our VLANs inside the building. And it also has a layer 3 connectivity back to our main network, back to our campus network. All right. Are there any questions? Because we're all the way up to STP now, the concepts. Any questions about VLANs, trunking? At this point, you should really have a pretty good understanding of, how a switch works. So basic switching. Okay. So you should have, how a switch works, basic switching. You should know how to create VLANs, what VLANs do. You should understand what trunks are, how trunks work, how to create trunks, and then inter VLAN routing. And remember our different methods. Our main methods were the legacy method, which was a single port per VLAN. And then we've got our router on a stick. On a stick. And then our last method was a layer 3 switch. Okay. Questions? We'll go over spanning tree and ether channel coming up. That'll be our 2 items we'll cover a little bit on Thursday, and also anything that you need on Thursday, please send me what you'd like for me to go over during the lab session on Thursday. I'd also like to talk a little bit about spanning tree and also a little bit about ether channel on Thursday. So I'll probably do that ether channel lab on Thursday so you can see it. And then we'll drop right into our DHCP and go from there, because we're doing pretty good. We're in good shape. I will tell you, we've only got a little over a month, but we've got about 5 weeks left in class. So please continue to work. I graded a bunch of stuff last week. I'll go back through and do a whole section again. If you're trying to catch up and haven't finished CCNA 1, please get that done as soon as you can. Because like I said, I've got that class going until August 31st, but I will have to turn that off eventually. And then we'll go from there. Are there any questions about the concepts or the ideas we've covered today, or anything that you need me to cover or talk about? I will tell you, I was in discussions today with the Palo Alto Networking Academy, and we may have some slots for anybody who would be interested in free instructor training for Palo Alto down the road. We may have a couple slots open. So if your school is interested, you may want to contact me and let me know. We're going to limit it right now. We've only got 25 slots, so it'd probably be a single slot per school. But if that's something, if you've thought about adding some firewall training or things of that nature from Palo Alto, if you're associated with us as a Cisco Academy, we will help you with your VMware academies, your Palo Alto academies, your Red Hat Academy, anything that you teach any of those academies, we will help you with it. So that's one of our full package deals. We help you with any of the different academies. So.
Well, what level of the training is the Palo Alto?
The Palo Alto is the first level firewall class, but I would say someone would have to have already had, or at least understand the concepts of what we've done in CCNA 1 before they even think about doing the Palo Alto, because it gets into how to filter based upon ports and IP address ranges and those types of things. So you really need to understand that Cisco 1 level first. So I would not put anybody into it who wasn't at least at that level before they got in there. Okay. Any other questions about anything about our class?
I did put in there because I couldn't remember who said it. I thought it was either Tracy Williams or somebody said about Pearson View and linking to those session for books, because I went there and saw some good ones and I can't remember where the link was now.
You talking about O'Reilly?
It was out of O'Reilly, yeah, but somebody said as a sideline, and then during the time, rather than click on it, I just copied it and now I can't find my link.
I can send you the URL to the Pearson stuff. You want to look for Pearson Higher Ed. And it's listed under networking and Cisco. That's where you can typically find it under Pearson, but you go to Pearson Higher Ed.
Okay, thank you.
Yeah, and you sent that, I think,
In the
last week.
chat.
Yeah.
Yeah.
In the chat. Okay. Ooh, my lights just blinked, y'all. Okay, I'm gonna call it a day because, like I said, I think I'm getting ready to lose power here. The data center will be fine. My office won't. All right, everybody. Thank you so much. Have a good day.
Thank
You too.
Bye-bye.